In this video, we will look at PID, which stands for Pixel Diffusion Decoder, not latent-based like the other image models we saw previously. These are the text-to-image models that work with NVIDIA's PID models. Here, it says the model operates in pixel space rather than latent space and produces a super-resolved image in a single pass. Usually, a model generates an image, and then the second pass is about upscaling. But in this case, the model does the image generation and the super high image resolution in one pass. Do note that the word upscale is not mentioned here. The model draws the image in super high resolution. This model, or I should say the checkpoints, is 4-step distilled, so it should be fast. Below are the encoders this model can work with. The reason we need this encoder is that PID decodes and then starts working on the image. Below are the details of the checkpoints released and the encoders compatible with the checkpoints. I will be using this AE.SafeTensor as it works with Flux and ZImage model. The repository has been created by ComfyUI containing the model files. Below is the directory where you need to place the SafeTensor files. Inside files and versions, we get to see the models. The name of their files contains information related to the VAE, the size of the image to be given, and then the size of the final image we can expect from the model. This is the workflow I will be using, and this workflow was shared in this discussion. When anyone says they made the workflow, it is actually taken from here. The problems encountered were discussed, and this workflow is the solution. So let's look at a simple text-to-image workflow where I am using this Gemma model for the prompt and this BF16 file, which was downloaded from Hugging Face. Note that this MXFP8 performs better on a Blackwell card, but I am using the BF16 for best results. The model above will expect an image to work with. The prompt used here is the default present in the workflow. And this is the result. The structure of this workflow looks similar to the workflow using the stable diffusion model. But the things under these nodes are working differently. Now let's look at the image-to-image workflow. The model selected here takes an image, encoded by the VAE, which is used with the Flux 1 model. And this model will take an image of 512 pixels, which will be enhanced or upscaled to a 2048 pixel image. I will use an image with lots of objects in it. And this resize node is used to make it a 512 pixel image. The resized image is encoded using this VAE. The VAE used here is the same we use for the Flux model. The image becomes a PID condition for the final image, and the prompt here needs to be changed. The condition node should be on Flux, as we are giving an image encoded by the Flux VAE. And the second value here, named as degrade sigma, shows the amount of changes this model can make in the process of increasing the resolution of the given image. I will keep it at 50%. Below are some settings that work well at default. You may change the size of the empty latent image if your image is a different aspect ratio. But then this may generate a bad result. Then these are the two options for sigmas. Let's run the workflow. The image I gave is larger, so I will decrease it further. The image generated still looks good. The time it took was around 6 seconds on my 5060 Ti 16 GB. The comparison shows a significant difference. I was not expecting these patterns. I will decrease this value here, which should restrict the model's effect. Some patterns are still visible on the rock. This is due to the prompt I took from GPT. I have changed the prompt. Now these are just keywords for increasing the details. The patterns did not appear now. The face is not consistent. The image looks good to me, but this is not an upscaler for sure. It is an image enhancer that increased the resolution as well. You can put your bad images here, and this model should do the magic. The workflow below is the same as above. The difference is that it uses the basic scheduler. And the model used here takes a 1024 pixel image and outputs a 4K image. I will use the same image and an image compare node to see the difference. The given image is 1024 pixels, and the image looks okay. I forgot to use the prompt. Changes are clearly visible, but this is not a 4K image, though you can generate a decent image using a 4K model. I will increase the resolution here to get a 4K image. The previous image was generated in 6 seconds, and this image took 55 seconds. The result is really great if subtle changes are acceptable, but I don't think it will be useful in my work. The clients I am working with currently will not accept these subtle changes with their character. But the background looks acceptable. There might be a different use case. This is another workflow where the image is generated using the Z-Image Turbo. The image output will be 1024 pixels, and below is the PID workflow, which should give out a 4K image. The prompt here is about a crow and a red panda in their natural habitat. This image node I was using to make this an image-to-image workflow, where I was trying to increase the details using Z-Image Turbo and then enhance the same image using PID. The results generated were really good. The image generated is good. You should use this if you are using the Z-Image model. This image enhancer works best if you are working with a recommended resolution with the aspect ratio of 1:1. Using an image with a different aspect ratio produces a bad result. The same was discussed here, and a fix was later added by Kijai in this node. In this workflow, all the values goes into 2 different K-samplers. In the first K-sampler, the model connection goes to the K-sampler. Directly after this, the SD3 node. In the second K-sampler, the model goes through this context windows node. I will select an image with a completely different aspect ratio. The model selected here is expecting a 1024 pixel image. The prompt here can be simple, and I will run the workflow. The time it took was 98 seconds, and the difference is clearly visible. The context window node is technically a memory management node. The way it manages in simple terms is to divide the task into small pieces and work on those pieces one by one. The context length and context overlap are the 2 options controlling this task. This workflow and the models released by NVIDIA are not going to replace our older upscalers like the Seed VR. This image is the worst image generated by me, using the first version of the Flux model. If I process this image now, the result I get is not so great. Actually, the image itself does not have the details required to build on. The workflow will be shared in the description, but make sure you have the custom node, ComfyUI KJ nodes. And here you will need the RG3 nodes for comparison. Also, make sure you update your ComfyUI using this update batch file, or run this file if you are on the stable version of ComfyUI. So that is it in this video. I hope the video was informative. I wish you an excellent day.